Hi all. My name is Olivier Sela, and thank you for attending the session. The goal here is to present the results of the third module in the AI product management specialization proposed by Duke University. And this third module is about ethic in AI. So the goal is to present regarding the topics I've chosen, which is from the second module. So the main context is about the optimization of energy consumption in a building based on frequency and also presence of people in this building by optimizing the number of floors that needs to be kept open or not in a headquarter depending on the frequentation. So the problem description is what I've just said for a headquarter office. The focus is on how to optimize the heat and cooling usage, as also the cleaning processes, that is a number of intervention from an external company for cleaning in a flex office building, considering all employees or declaring their presence in advance. So the key task is the determination of the floors that needs to be kept open and for which we need to plan actions regarding cleaning and also consumption. What is the consumption in terms of energy of these floors? So the user at the end is a facility manager, that is the person owning the building and wanting to optimize its management. And the task is to optimize its consumption and cleaning action based on the people presence. So if we look at all the tasks that have been identified regarding these goals, so the task one is about the trigger. The trigger means when the model is started. So this is the case when data are available, new data are available for loss consumption, as also people counting, and also the cleaning planning. So the second task, once this is available, is to collect this data for consumption only, and the inputs related to this task are the sensors. From this, there will be some calculation performed regarding the consumption per floor based on the number of people, or reported to the number of people. The next point is to collect all the information about the cleaning interventions, and then in task 5, to calculate the cleaning intervention relative to the number of people per floor. Then in task 6, from the predicted consumption, so and number of people, there will be predicted used floors that needs to be kept. So it means that based on this, it's possible to decide which floor needed to stay open, as there are a lot of people to let's say to come or not. And we'll do the same in task 8 and 9 for the cleaning intervention. That is, we're predicting what it will be the number of people on site per floor to see what are the floors that would need cleaning or not. And on this information prediction, we can decide which are the floors that needs to be cleaned. So the objective at the end for the facility manager is to have a system used for optimizing this energy consumption as also cleaning of buildings. So the main tasks that could be optimized thanks to ML or AI, the model, is the task 2 and 4 related to the data collection. It means that these tasks can be done automatically rather than providing by hand this kind of information. As also the tasks 7 and 9, where it is decided which are the floors that could be potentially closed, compared to their energy consumption, and the cleaning needs. So in terms of UX conception, how the user will interact with the solution. So at inputs, the data are automatically and transparently collected from sensors or cleaning planning when this planning is defined. Considering the cold start of the system, an heuristic-based approach will be used for the first predictions to be done. In terms of outputs, the results are presented to the user as a dashboard of predictions, summarizing the floors with frequentation, that is number of people per floor expected. So with a probability that this number of people will be on this floor specifically. Also, there will be suggestion of what are the floors that could be closed based on this information regarding frequentation for energy and for cleaning interventions. In terms of feedbacks, so in the gathering of user feedbacks, on this dashboard, the user will have the possibility to give the feedback to confirm a prediction, that is a proposal of closing this or the other floor. So the user will just click and confirm, okay, that I'm accepting the closure of this and this floor, just to track for the model what were the best prediction that are considered as acceptable by the end user, so the facility manager. So this will help them to refine the model and understand, let's say, the thresholds considered by the humans, so the facility manager, to take his decision. The transparency of the model is ensured by indicating on dashboard which data, that is energy consumption and number of people, so which data are used in order to determine how and which floor has to be enclosed. And about the uncertainty communication, so the uncertainty will be expressed to the user, meaning that for each day, there will be, let's say, a set of different people that have been calculated per floor, what is, let's say, the minimal, maximum, and expected number of people. And for each, there would be a probability that this number of people would be reached this particular day. So it means that the prediction would provide here a percentage of what is expected number of people at this floor. And this is done for each floor. About the privacy of the data managed and processed by the model, we are not dealing any personal information. So with the system, only consumption, that is energy consumption information from sensors, or number of people. We are not tracking specifically people, just counting a number of people, as also using the declaration of people who plan to work on site. So we are not looking at who is asking what, but how many people at the end would be present on site. The location of the installation is based in Europe, and the system needs to comply for this reason with the European Union laws. But in this specific case, there is no privacy to be maintained. As said, we have no personal information as part of the set of data we process. About the ethical consideration, we can identify three different biases. One about the data collection, related to the fact that in the historical bias, there could be some data not representative to what is a normal situation. For example, if in our history of data, there are vacations days that happen during this historical set of data, which means that we may consider that there would be less people. Regarding training and evaluating, there is a possible learning bias. The historical data used for training our model may not be representative of real situation, especially related to this question of vacation day off or these kind of things. And the last risk, let's say, of bias, it's about the deployment. For example, in the case a facility manager is not using our solution only to optimize the floor, let's say, user or floor decision for closing or not this. If, for example, he wants to use this same model to track energy consumption per floor only, this won't be the right objectives, because here prediction are always in relation with a number of people. It's not related to a real consumption of energy by the building without considering the number of people. So it cannot be used just for energy consumption optimization. So last point about ethical AI, how the product would fulfill this ethical AI in terms of fairness. We have not information related to individuals, so there is no risk being unfair towards people. Accountability is ensured by, let's say, being in line with the European GDPR laws. In any case, even if we don't have personal information, there will be always a specific spark, so a single point of contact identified in case of some inconsistencies are noticed by the users. Regarding the laws or personal data protection, even it should not happen theoretically, this spark is mandatory just to be sure to consider properly the customer request. In terms of transparency, the minimal occupation percentage considered by the model to predict and propose floors closure is explicitly communicated. So it means that the prediction provided by the system is a recommendation in terms of which floor needs to be closed. But it needs at the end always to be confirmed by the facility manager, and to help the facility manager in his decision in terms of transparency, there would be a percentage of potential closure associated to each proposal. So thank you for your attendance, and hope this will fulfill your expectation in terms of presentation. Thanks a lot.